Hey everybody, another video here. We are going to look at the two lists that I have pre-created here. A list of numbers and a list of names. Some teacher people. I'm going to show you how to search and also sort a list. So let's begin. Let's say we want to determine if something exists in a list. In other words, is it present in the list? So let's say, for instance, if 4 in numbers. So is the number 4 in the list of numbers? Print, yes, 4 is in that list. Else, print, no, 4 is not in that list. So you have an if statement. It's not using less than, greater than, equal to. In this case, it's using in it. A true and false thing. Is it in there or not? Let's test that out. And of course, 4 is in that list. Let's say, just real quick, I sneak that out of there. Let's say it's not in the list anymore. Is 4 in there? No, it's not. And, keep in mind, when we have just the number 4, it's not looking for, like one number in the numbers. Like 4 would not trigger in 42. It's the exact match. This, of course, works the same as if you have the list of people. If me is transparent, in people, print, yes, he is in there. Let's try that. Ta-da! Yes, he is. And this doesn't have to be an exact match. It also could be a variable. I could put something like num equals 4, and if num in numbers is the number 4 in there, and of course, as you would expect, yep, works just perfectly fine. So if you want to figure out if something is in the list, use the if in trick here. If you want to figure out where it's located, you can do that as well. The index command, I can say, where is it located? So how about we say people dot index, parenthesis, quotes. So I have the if statement first and saying, like, if it's in there, say, yeah, it is, and then say where it's located. So I would be in position 0. And so let me just run this real quick. It should give me 0, and in fact it does. So I could add on a little bit of text here. I could say something like, he was found at location, and then comma people. So the index command, excuse me, the index command will give you where it's located. If it's not in there, well, that'd give me an error. So just make sure you do it within the if statement to say, like, if it's there, because if you say, like, people.index of, Michael Jordan, it's not gonna work because it's not on the list. So, just use this in coordination with this one here. Let me put a little note here. The dot index command will give you the location of the elements you're looking for. So, all right, a couple other things then. I intentionally put this list of people out of order alphabetically. So let's say I want to sort the list. Well, what's nice about Python is Python's a modern language and it has a lot of nice built-in commands. And there's a nice little sort command that's going to put your list in order. Now, here's the thing. Those of you that are going to go on into later computer science courses, there are many different sorts, and in a lot of languages, they're not so easy. I'm not going to get too in-depth with that. That's the purpose, one of the purposes of the second year class. We'll talk all about the different kinds of sorting algorithms ways to sort a list. I know it probably seems crazy that, oh my gosh, like why is there more than one way to sort a list? Well, I promise you there's lots of different ways. But again, that's a conversation for another time. Let me just show you the quick, easy way to do this in Python. I'm going to say, what's our name of our list? People? Yep, let's say people. So people dot sort. Is that easy? Well, here, check this out. If I say print people, that should print the unsorted list. Then I sort it. And then if I print people again, wait for it, magic. You have the unsorted list. Now you have the sorted list, A through Y, I guess, in this case. What you gotta be a little bit careful of here, I did this on purpose. Let me just rearrange some things. Let me make this is app's name lowercase. Try this again real fast. So now notice it puts the A after these names. It goes back to what we talked about Unicode and ASCII. In ASCII, the only letter number that I asked you to remember was capital A is 65. Capital A is 65. So when it sorts the list of words, numbers are no big deal because numbers, there's not like uppercase, lowercase, but words are a little bit different. On a computer, the characters, the letters, they're uppercase. Capital A is 65, so B is 66. It orders them based off that because the computer doesn't really know what the letter A is. It thinks of it as a number in binary. So lowercase a is 97. So the uppercase letters come before the lowercase. So it'll sort all of the uppercase and then all of the lowercase. So if you have a mix and match, it does cause some problems. There are commands we'll talk about in the future which will make the cases consistent. But again, for right now, I just want to make sure you realize that when you sort the list, be aware that mixed cases, upper versus lower, may cause issues because 65 is capital A in ASCII, ASCII, whereas 97 is lowercase a. I'll put in quotes so it doesn't look like is A in ASCII. So you just got to be careful about mixing and matching those. It is what it is. So again, I mentioned this. I'm just going to briefly go into this. The sorting command here, the sort command, it's very quick and easy. Sorting algorithms themselves, not so much. Let me just give you a quick little preview. Sorting algorithms. So again, you're probably thinking like, oh my gosh, like how many sorting algorithms are there? Well, look at this chart. There's quick sort, merge sort, in-place merge sort, intro, heap sort, insertion sort, block sort, quad sort, tim sort, selection sort, cube sort. It goes on. And you're thinking, like, why are there different sorts? Why don't we just put things in order? Well, yeah, because you're a person. Computers need an algorithm. It needs a process. It needs a formula. And it's actually very complicated. There are some sorts that are good for small lists, some sorts that are good for big lists. There are some sorts that are good with lists that have a lot of unique numbers, and there's some sorts that are good for numbers that are almost already sorted. It's actually one of the reasons that if you take computer science as a major in college, they ask you to take lots of high-level math classes because a lot of this sorting algorithm stuff is based off of optimization. What's the fastest way for your given problem? And you can see here, like there's logarithms involved. If you don't know what those are yet, I promise you someday you will. But it's actually very math intensive. And so I just wanted to, again, introduce this. The second year class is where you learn more about this. But like I said, just a little sneak peek behind the curtain of Oz. So one more thing I wanted to show you here quick. People.reverse. Print people. probably can surmise what this is going to do. It reverses these sorts. So you can sort it A to Z, and you can sort it Z to A. You can just reverse it. And of course, if it's numbers, it puts them in numerical order, so nothing special about that. So, that is all for now. Thanks for watching. We'll do more with lists very soon. Take care.